Hello and welcome to this session in which we will look at yet another data structure whose value is a sequence, and this can be called as lists or arrays sometimes also. They differ from stacks or queues in the sense that they are more powerful and there are many more operations defined on these objects. So, stack and queues had some few simple operations like push and pop or insert defined for them. Lists have many more general operations already defined, which can be used more easily, and elements in a list can be accessed by their position in the list. So, position is also another type whose value you can think of are just numbers, or sometimes we also call it as an index in an array. So, list operations use positions in the list as parameters, and we will see that we can define many more operations on lists compared to stacks or queues. So, list position is another type whose value you can think of it as just a number. So, 0 is a position, and if p is a position, then there is a next position called next of p. Sometimes we also need a previous operation defined on numbers or positions. Previous of 0 is undefined, whereas previous of next of p is equal to p. So, given any position p, we can define a previous position to that, except for the 0th position where it is undefined. And usually we need only these two operations for positions. Given a current position, we can move to the next or the previous position. And list operations will usually use positions as a parameter for the operation. So, here is an example of an operation which finds the element in the list L at position P. So, we call this operation as element at. L is a list and P is a position, and this returns an element in the list L which occurs at position P. So, if the list is empty, then there is no element at any position. So, element at phi of P is undefined for all positions P. If the list is non-empty, that is, it is obtained by pushing an element x in some list L, then the element at position 0 is just the element x itself. So, if the value of the list is push x comma L, the element at position 0 is the element x itself. Otherwise, element at push x comma L, if the position is not 0, it is some next of p for some position p, then the element at position next p in the list obtained by pushing x comma L is the element in the list L at position p. So, notice that in this definition the element position changes when I push an element in a list. So, the element at position p in push x comma L is not necessarily equal to the element at position p in the list L. So, at 0th position, for example, when I push x in L, x takes the 0th position, whereas the original element which was at 0th position in L goes to position 1 in the new list obtained by pushing x in the list. So, here is another operation called insert, which inserts an element x in the list L at position p. So, insert phi comma 0 x. So, in the empty list, if I want to insert at position 0, we just push x in the element in the empty list. So, get a list containing just x. In the empty list, if I want to insert at any non-zero position, then there is no such position at which we can insert. So, we say it is undefined. So, inserting in an empty list at position next p is undefined for any element x. Now, if you are inserting in a non-empty list push y comma L at position 0 the element x, we simply push x into that list. So, its value is push x comma push y comma L. Otherwise, if you are inserting at a position next of p in the list push y comma L next p y, then we keep y as at the 0th position. So, this is obtained by pushing y in the list obtained by inserting in list L at position p the element x. So, this essentially inserts element x at position p and shifts all the elements right one position. Those that come after position p get shifted right by one. Similarly, we can define the delete operation, which deletes the element at position P from L. Deleting from an empty list is undefined for all positions. There is no element at any position in the empty list. Delete from the 0th position from the list obtained by pushing x comma L gives the list L itself. So, effectively removes the first element of the list. If the list is not empty and we are deleting from the position next of P from that list, then essentially we keep the first element as it is and delete from L from the position P. So, let us look at another function called first occurrence Lx, which returns the position at which x occurs in the list L for the first time, and it is undefined if x does not occur in the list L at all. So, first occurrence empty list x is undefined, empty list does not contain any elements. So, first occurrence of x in a list obtained by pushing y comma L, pushing y in list L is 0 if x is equal to y. If the first element of the list itself is x, then the position is 0. Otherwise, we find the first occurrence in L of x and return the next of that. So, the position will be one more than the position of x in the list L. So, next of first occurrence of L comma x returns the position at which x occurs for the first time in L. So, we can define functions on lists also using these operations. So, either you can define functions using the standard way, which is to define it for the empty list, and assuming it is defined for a list L, define it for a list obtained by pushing an element in L. Otherwise, we can use the already defined operations on list, and we can write more in a programming style the definition, which gives an iterative way of defining the functions rather than a recursive way. So, for example, finding the length of a list. So, length function can be defined as I define a variable called position whose value is 0. So, remember positions are just numbers. So, we can assign a value to a position P which is 0, and now while there exists an element in list L at P, we set P equal to next P, right. That is, while there is an element at position P, we keep incrementing P till you reach a point where there is no element in list L at position P, right. So, remember, element at LP will be undefined when there is no element in L at position P, and this will happen only when P becomes equal to the length of the list, and so we return P. So, this is the length function. Now, here is another function which extracts a substring from a list L starting from position P and position Q. So, it is up excluding the position Q. So, it finds the sequence of elements in the list L starting from position P to position Q, but not including Q. So, again we will create a new list in which we will essentially copy the elements from the list L. So, set position P1 equal to P initially and P2 equal to 0. We set a list else equal to the empty list, and while the position P1 is less than Q and element at L P1 is not undefined, there exists an element in L at position P1, we insert in S at position P2 whatever that element in L was at position P1, then increment P1 and increment P2 as well. So, we will keep inserting in S will be an empty list in which we will keep inserting one element after another at successively increasing positions starting from 0, and position P1 will start from P, and as long as P is less than Q, it will keep inserting the elements in S. Only thing is, if say P was greater than Q, then the substring is not defined at all, then we will not insert anything in the list L. And similarly, if the position Q specified is after the end of the list L, so that is at some point we get the element at position P1 in L is undefined, then we will not consider it as a proper substring. So, finally, only when P1 is equal to Q we will return the string substring S, else we will return it as undefined, the substring is not defined at all. So, here we are essentially using the already defined operations on lists rather than defining it using the standard way of looking at the empty list and a list obtained by pushing one element. So, we can write many different functions now using these operations. So, as exercise you can try to write a function to count the number of distinct elements in a list. So, you can do this in two ways. One is by defining using the standard way of defining operations, define it for the empty list, assuming it's list L, define it for a list obtained by pushing an element x in L. Otherwise, we can also write an iterative function which uses the already defined operations on lists, which allows you to access elements at different positions in the list, and we can write a function in a programming style which does the same thing. Right. You can try to see which way you find easier of the two. Both of them are ways of defining this function, but some ways are more convenient than others for different functions. So, here are some more exercises. So, suppose I consider the list obtained by inserting at position P an element x in the list L, and I delete the element at position P. Will I always get back the list L? So, I insert an element x at position P and delete from the resulting list, delete the element at position P, right. So that this will always give you the same list, provided these functions are well defined. So, if the position P is well defined in the list L, then show that this will always be true. Also write a function to change the element at position P in a list L to x. So, if L does not already have an element at position P, this should be undefined, otherwise it changes the value of the element at position P in the list to x. So, this is different from inserting the element at x. We are essentially replacing the original element by a new element rather than adding a new element to the list. So, try these as exercises and we will continue further later. Thank you.